friends, till now we have discussed about the interaction of radiation with matter, and we have gone through the three processes, that is absorption, spontaneous emission and stimulated emission. Further, we have derived the relation between the Einstein coefficients associated with those three processes, right? Today we will see how we can use these relations to find out what is the requirements for amplification of light in case of a laser. So coming to the different rates associated with the three processes, we have already derived that the rate of absorption is equals to minus dN1 by dt, and that is equals to B12 N1 E nu 12. Here N1 is the population in the ground state or state 1. B12 is the Einstein coefficient of absorption, and E nu 12 is the energy density. Further, we have taken this E nu 12 as E nu for convenience of our use. Then we have seen that the rate of spontaneous emission is equals to minus dN2 by dt, and this denotes us, this is for spontaneous emission. And for this what we have obtained, this is equals to A21N2, right? Here this A21 is the Einstein coefficient for spontaneous emission, and N2 is the population in the excited state or state 2. The third process which we have already discussed is the stimulated emission, and the rate of stimulated emission is equals to minus dN2 by dt, and this ST denotes this is for stimulated emission. And for this what we have obtained, this is equals to B21N2 E nu 12. B21 is the Einstein coefficient of stimulated emission, N2 is the population in the excited state or state 2. E nu 12 is the energy density. Further, we have substituted this E nu 12 as E nu for convenience of calculation. Okay. Now, coming to the requirements for amplification. As we have already discussed, though there are three different processes associated with the interaction of radiation with matter, for amplification of light, what we have seen that the stimulated emission should dominate over spontaneous emission and absorption, right? Now coming to the relations what we have obtained, this is the first equation, B21 by B12 is equals to 1. From here I can write B21 is equals to B12. And the second relation we obtained is A21 by B12, that is equals to A21. In place of B12 I can write B21, and that is equals to 8 by h nu q by cq. So these are the two relations developed by Einstein, which are known as Einstein equations, right? Now coming to our discussion, we know that the light amplification occurs whenever the stimulated emission dominates over absorption and spontaneous emission. So the lasing action occurs when stimulated emission dominates over spontaneous emission and absorption. Now we will try to derive some conditions under which this will be satisfied, and those conditions we will be deriving from these equations which are developed by Einstein. So first we will see when this stimulated emission will dominate over spontaneous emission. What is the requirement or under which condition this stimulated emission will dominate over spontaneous emission? For doing that, we will be finding out the ratio between rate of stimulated emission and rate of spontaneous emission. If we will find out this ratio, if this is greater than 1, definitely this stimulated emission is more as compared to spontaneous emission. If it is 1, both are same. If it is less than 1, then spontaneous emission will dominate. Okay, but we need a situation where this stimulated emission should dominate over spontaneous emission. Okay, so for this ratio I have just substituted these values. This is the rate of stimulated emission, that is B21 N2 E nu, and rate of spontaneous emission is A21 N2. From here I can cancel this N2 and N2. After cancelling I will get B21 by A21 E nu. So from here I can tell that this value will be more if I am increasing the value of this E nu, which is nothing but the energy density of the incident radiation, right? So the stimulated emission will dominate spontaneous emission if the incident energy density is high. If this E nu is high, then definitely this ratio will be more, and hence stimulated emission will dominate over spontaneous emission. But if I am increasing the energy density of the incident radiation, there is probability that that will also increase the absorption process, right? Because absorption also depends on the energy density. So if absorption process also increase, there is chance that absorption may dominate over stimulated emission. So this is not the only condition under which we can get stimulated emission dominating over spontaneous emission. So this may also lead to high absorption. So to incident high density radiation is not the only condition. This is one of the condition, but this is not the only condition for ledging action. So what else we can do? The first condition we got that the incident energy density is high. If it is high, let this is the ground state, this is the excited state. Okay, this is ground state and this is our excited state. Now if energy density is high, that means this absorption will also takes place. At the same time we are getting spontaneous emission, and this incident radiation will also trigger the stimulated emission, right? But we can increase this stimulated emission if this atom which is moving to the excited state because of absorption, if it can stay here for longer time. If it will stay here for longer time, then that incident radiation will hit this one and that will lead to stimulated emission. So another condition is that if this atom which is moving to the excited state, if it will stay here for longer time, then there is more probability that we can get more stimulated emissions, right? So the longer lifetime at the excited state increases the probability of stimulated emission. This is the second condition. First we have seen that the incident energy density should be high. Second condition is that the excited atom which is moving from the ground state, that should stay in the excited state for a longer time. That means longer lifetime is the second condition. Now let us see what is the requirement to dominate stimulated emission over absorption. Okay. So for that we will be finding out the ratio between stimulated emission and rate of absorption. So rate of stimulated emission is equals to B21 N2 E nu, and rate of absorption is B12 N1 E nu, right? And we have already seen that B21 is equals to B12, so I can cancel these two. Okay, and here I can cancel this energy density E nu. So what we left with, that is equals to N2 by N1. So here this stimulated emission will dominate over absorptions only when this is greater than 1. Okay, that means N2 should be, from here I can write N2 is greater than N1. So this should be the condition under which this stimulated emission will dominate over absorption, right? So stimulated emission will dominate absorption only if the number of atoms in the higher energy state is more than that in the lower energy state. Higher energy state is N2 and the number of atoms in the lower energy state is N1. So only when N2 is greater than N1, then this stimulated emission will dominate over absorption. So this is the third condition. And this situation, when this number of atoms in the excited state is more than the number of atoms in the ground state or lower energy state, that condition is known as population inversion. So this is the third condition to be satisfied to get light amplification. Okay. So to summarize, what are the requirements we got? We got that the first requirement is the incident energy density should be high. At the same time, if we have longer lifetime at excited state, then that will increase the probability of stimulated emission. Now coming to the third condition, that is population inversion. So these are the requirements to be fulfilled to get light amplification in case of a laser. Now the thing is how to achieve these conditions, how to fulfill these requirements. So that we will be discussing in the next class. How can we achieve these conditions so that we can get the light amplification. Today we will stop here. Thank you all for your listening. If you like the video, please press the like button and share the link with your friends. Also do subscribe to my channel to get the notification whenever I am uploading a new video. Thank you all.